Okay, now let us try to solve this problem. Now the curve which is 2y square is x cube, and when you differentiate with respect to x, we get that as 4y dy by dx is 3x squared, and then dy by dx is equal to 3x squared into 4y. Okay. Now m1 would be the slope of the tangent at 8, 16, that is 3 multiplied 8 square, right, divided by 4 multiplied 16, right, which gives 3. Okay, we got the slope of the tangent at 8, 16. Now let us consider another curve, that is y square is equal to 32x. Okay, now differentiating both sides with respect to x, we get as 2y dy by dx is equal to 32. Okay, now this gives dy by dx is equal to 16 by y. Okay, and let m2 be the slope of tangent at 8, 16, which would be 16 by 16, which is 1. Okay, now if theta is the angle between the two curves at 8, 16, so tan theta is equal to 3 minus 1, right, divided by 1 plus 3 into 1, right, so which gives us 2 by 4, which is 1 by 2. So now the theta is tan inverse 1 by 2. Okay, so let us move on to the next problem. Okay, let us find the solution for this. Now denote x as a side of the square shape, and a denotes the area, so we get a is equal to x squared, which is squared, so squared, right, so it is x squared, so keep that equation as 1. Now differentiating this with respect to t, which we get as dA by dt, which we have to determine, right, so that is equal to is equal to 2x dx by dt, right. So now the rate which we have been given is 2.5 centimeter per minute, so that will be 2x multiplied 2.5, so that is 5x. Okay, now when x is 9 centimeter, when x is 9 centimeter, so dA by dt, we get that as 5 multiplied 9, so which is 45. Okay, so this will be the square centimeter per minute. Okay. the rate of increasing the area at x is 9. Now let us look into mean value theorem and using or Lagrange's theorem, right? So let us solve this. Okay, let us verify the mean value theorem, okay, for the function f of x, which is 3x squared minus 7x plus 2 in the interval (1, 3). Okay, let's see the solution for this. So f of x being a polynomial where x is continuous and differentiable in R, and f of 1 is 3 minus 7 plus 2, which gives out to be minus 2, and f of 3, right, over the interval 3, right? So f of 3 would be 27 minus 21 plus 2, which gives out to be 8. So f of 3 minus f of 1, so this is 3 minus 1, so this gives out to 8 plus 2 divided by 2, which is 5. Okay, so f dash of x would be 6x, right, minus 7, right, differentiating with respect to x for the f of x, which is 3x squared minus 7x plus 2, and f dash of c is f of 3 minus f of 1 divided by 3 minus 1, which is 5. Okay, now 6c minus 7, which is 5, right? Now we get c value as 2, which lies between 1 and 3, right? So it is interesting to note that the point C is the arithmetic mean of 1 and 3, right? So okay, so this is 4 by 2, which is 2, right? Yeah. Okay, now let us look one more problem to verify the mean value theorem here for the function, which is f of x is sine square x. Okay, and a being 0 and b is pi by 2. Okay, let us solve this. Now f of x is continuous and differentiable over the interval 0, pi by 2, and f of 0 is 0, right, and f of pi by 2, which is equal to 1. Okay, now f of pi by 2 minus f of 0 divided by pi by 2 minus 0, so this goes out to be 2 by pi. Okay, now f of x is sine square x, so f dash of x will be 2 sine x cos x, which is sine 2x, right? And by mean value theorem, f dash of c, which is f of pi by 2 minus f of 0 divided by pi by 2 minus 0. Okay, so this is 2 by pi, right? Now now we got as sine c 2c, which is equal to 2 by pi, right? And this implies c is 1 by 2 sine inverse 2 by pi. Okay, and note that c is 36 degrees, and therefore c lies between 0 and pi by 2, right? C lies between 0 and pi by 2, that is 36 degrees. Okay, that is, yeah. Now let us use L'Hopital's rule here. Okay, L'Hopital's rule here. Okay, let us evaluate limit as x tends to 0 sine 5x by sine 9x. Okay, now f of x is sine 5x and g of x is 9x. So when you substitute x as 0, so this reduces 0 by 0, which is indeterminate form. Okay, when x takes the value of 0. Okay, so therefore by applying L'Hopital's rule here, so limit as x tends to 0, differentiation of 5x is 5 cos 5x divided by, this is 9 cos 9x. Okay, now by applying x as 0, we get 5 by 9. Okay, so let us look at another problem as limit x tends to 0 e to the power of x minus e to the power of minus x divided by sine x. Again, by substituting x as 0, we get 0 by 0, which is an indeterminate form. Okay, now by applying L'Hopital's rule here, now this is limit x tends to 0, this will be e to the power of x, and this is plus e to the power of minus x divided by cos x, right? Now by applying x is equal to 0, we get 1 plus 1 divided by 1, which is 2. Okay, let's look at another problem. Is limit x tends to 0 x minus sine x by 5x cube. Okay, now when you substitute x as 0, okay, so you get this as 0 by 0, which is indeterminate form, and by applying L'Hopital's rule here, we get limit x tends to 0, this is 1 minus cos x divided by 15x square. Again, when you apply x as 0, so you get 0 by 0. Again, differentiate with respect to x by L'Hopital's rule. So limit x tends to 0. So this would be, cos becomes sine, so plus sine x divided by, this is 30x. Again, this would be 0 by 0. So again, differentiating with respect to x, this would be cos x by 30. So when you put x as 0, so I get 1 by 30. Okay. Now let us look at another type of problem here to find the limit as x tends to 0. This is a log tan x by log tan 3x, right? Now when you put as limit x tends to 0, right, we get as infinite by infinite, which is in the determinant form. So again, by using L'Hopital rule here, limit x tends to 0, so log of this becomes 1 by tan x, and tan will be secant square tan x, right, and multiply 10. So this divides by 1 by tan 3x, and this is secant square 3x multiplied 3. Okay, so we separate it now. 10 by 3, which is constant, multiplied limit. Now we'll take secant together, so secant square tan x by secant square 3x, right, as x tends to 0, multiplied limit x tends to 0, so we'll take tan 3x by tan x, right. Now as you put x is equal to 0, this gets okay with it, so we get 1. Okay, but we are not okay with when you put x is equal to 0 for tan 0, if it is tan 0. Okay, again differentiating with respect to x. Okay, we get limit x tends to 0, so this is secant square secant square 3x by secant square tan x, and this is 3 by 10, right? So this, when you cancel out, we get as 1. Okay, let us look at another problem. Limit x tends to 0, 1 minus e to the power of 2x mod 3x. Okay. Now when you as limit x tends to 0, so this is 1 minus 1 multiplied infinity, which is 0 multiplied infinity form. Okay, and or which is indeterminate. Okay, or we can, even if you find 1 minus e to the power of 2x by tan 3x, you get in the form of 0 by 0 form when x tends to 0. So by applying L'Hopital rule here, so this is minus 2 e to the power of 2x divided by this is 3 secant square 3x. Now when becomes 0, so this is minus 2 by 3.